Hello and welcome to section 4.5, integration by substitution. And so all of this is going to be trying to make our lives easier. This is going to be kind of undoing the chain rule that we have dealt with before. So before we dealt with something like this that said y equals, say, something like 1/3 of x squared plus 1 cubed. And I ask you to take the derivative of that. Well, that would have been, well, 1/3 times the 3, the power, times x squared plus 1 squared. And then we have to multiply by the chain, which is the derivative of the inside, which is 2x. And so then y prime, when we multiply these together, would be x squared plus 1 squared times 2x. And so that should look familiar, that this function up here was the derivative. That should be our final answer when we do this. And so things that we need to recognize is that basically that our f of x, in this case, in this problem up here, is the parentheses with the function inside squared. The g of x is the inside function, which is x squared plus 1, and g prime of x is 2x. And so then basically what we end up doing in this case is we can try to rewrite this with what we call a u substitution. So what I'm going to do is I'm going to say, okay, well, I've got this function that is x squared plus 1 squared times 2x dx. So there's my function. If I recognize that x squared plus 1 is my inside function, let's rewrite that as u equals x squared plus 1. Then I will take the derivative of u, and I'm going to use differentials. The derivative of u would give me, if I take the derivative of this, I will get 2x with a dx tagged on. So now you'll notice that this 2x dx could replace this guy right here, and the x squared plus 1 could replace that right in the inside there. So with that being said, I end up with a new function in terms of u that would say, oh, well, that u squared, which would be this guy, the green thing with the squared, and then 2x dx is now du. Which this whole change makes it easier for me to go ahead and integrate, and when I integrate this I get u cubed over 3 plus c. And so now rewriting this, if I was to substitute in what u was, well, u was x squared plus 1, so I could write this as 1/3 times x squared plus 1 cubed plus c. And don't forget our constant of integration, because we don't know that this thing may have started at 0 or may have started somewhere else, and so we needed to make sure that we hung on to this constant of integration. So you'll see that the terms, when I took the derivative and did the antiderivative of it, I basically got the same thing. So we have some guidelines that go along with this, and the guidelines are pick your u value, that's your inside function, then take the derivative of it, rewrite it, and then find the resulting integral in respect to u, and then plug back in. So let me make these guys parallel to one another, and you can kind of see my steps that I did. Well, the first thing I did is I recognized my inside function was x squared plus 1, so there was step 1. Step 2 is then to rewrite it. That was giving my u value. Step 2 was to rewrite it, take the derivative of that. The third step was then to write it in terms of u. And then the fourth step was to take the antiderivative. And the last step was to resubstitute. And so that's really all we're doing. And so we're going to practice this again and again and again. And so then our next thing that we have after our guidelines is this basically the general power rule. And the general power rule is saying all the things that we've done before, so there's really nothing new. You can go ahead and copy this down, pause it, and copy it down if you like. And then finally, what happens if it's a definite integral? Well, you have two options for this, and we'll talk more. I'll talk a ton about this, but you could have something like this. We'll go with an integral that goes from 5 to 7 of x squared dx. Well, and now this doesn't seem like a very big thing to do. All right, so let's change this. Let's make it x squared plus 1 squared or something like that times the 2x. So we'll go back to the problem we had before, but this time we're going to go to 5 and 7. We're going to go 5 to 7 in this case. So we would go through and do our antiderivative of this function, and we'd still get our 1/3 of x squared plus 1 cubed. This is from the first example that I gave you. But instead of instead of doing all of this and going from, and we could go from 5 to 7, we could plug those in and get the value. Well, the other option is that at u, when we say that u is x squared plus 1, and then we could plug in this 5 value and the 7 value and rewrite the integral all in terms of u, because remember, if I don't want to have to substitute back in, then basically what I would end up with, okay, so let's say if I put 5 in, that gives me 25 plus 1, which is so if we say u is 5, then, and my x is 5, then I get 26 for that value, and if u is 7, I end up with 50. So now I would just do the integral from 26 to 50 of u squared du, which now I don't have to resubstitute, which basically gives me 1/3 u cubed from 26 to 50. And basically it's just a matter of where I substitute, because at this point over here, if I was to put in the 7, I would get 1/3 of 7 squared plus 1 cubed minus 1/3 of 5 squared plus 1 cubed. All right, no big deal. But then over here, well, 7 squared plus 1 is 50, and 5 squared plus 1 is 26, and so it gets you the same spot. We'll talk more about this in class, but I just wanted to make sure that you have this. It's just a way to kind of save yourself some pain and suffering along the way. So if you have any questions about what's going on, please come to class with your questions, and we'll talk more.